Here we go. Today we are Module 1, Lesson 8, and we're studying how to add and subtract polynomials. Now, I know what you're thinking. You're thinking, Mr. Kinder, what is a polynomial? Whoa! I will tell you in just a minute. So behind me is what I'm going to be using to show you how easy this is. Okay? So by the end of this lesson, you're going to be able to add and subtract polynomials. Here we go. All right. So let's go through a couple things. One, when we look at a polynomial, we notice that there are different powers. And a lot of times you'll notice that the number 1, the power of 1 is not written. These are called terms. Individually, they're called monomials. In other words, mono meaning one term. Together, they are called polynomials, many terms. And so what we're really looking to do, in effect, is to look for any term that has the same power. So for instance, in this particular one, you'll see that they've equated rewriting this expression, omitting the 1, and they just write it like this. They go ahead and put this 2 times x squared as 2x squared, 7 times x as just 7x. And so we omit the dot or the multiplication symbol, and we just put the number in front of the letter. So in our first activity, we're going to actually substitute 10 in for x to see what value we come up with. And so our first action is just simply to take the expression x squared, x cubed. I'm going to rewrite it. And then below, every time I see an x, I'm going to put in parentheses. And then I'm going to substitute in the value of 10 where x is. And this is where I might go to my calculator, and I might go ahead and use the calculator in case these big numbers happen to be more than my mental capacities can stand. In this particular case, 10 cubed is 1,000. 10 squared is 100. And we just keep going down the order here of operations and multiplying until we get down to addition. So our final answer is 1,273. So again, plugging in numbers, it starts with a process of every time you see a letter, the best process is to actually put parentheses and then plug in. And so one of the things that we're going to be doing is finding out what the value of an expression is when x is some number. And so that's what example 1a is illustrated for you here. Let's look at another example. Okay, so not all of them are as easy as just plugging in 10. So this one, you see there's a big difference. We're plugging in 2/3. We're going to do the same exact thing you saw me do earlier. I'm going to rewrite the expression, except every time I see an x, I'm going to put parentheses, and then I'm going to go back and put in 2/3. Now this one says what number is represented, and they give you actually 2 of them. If x is -2 or if x is 2/3. So we're going to do -2 first and see what that entails. Plug in -2 first. So this one's first example is kind of easy. You just plug in -2 and then follow the order of operations. And then 17 times negative 2 is a negative. What is 17 times 2? Well, I believe it's 34. Again, order of operations, multiply before we add and subtract. (16 minus 34), 16 plus 2. We can also do a little mental math here, and I have 18 minus 34, which my now answer is, since these numbers are different signs, we're actually going to subtract 34. 34 minus 18, if someone in the calculator has that answer right now. If not, you can just over here do a little math, and it should be negative 16. So negative 16 is what we get when we put in negative 2. Now, this one's fairly easy. The next part says, what happens when you put a fraction in? And so now I'm going to come back and I'm going to put the same thing, same expression, except this time I'm going to plug in 2/3. Now I'm going to probably need a calculator on this one. We'll see. So 2/3 squared is 4/9 plus 17 times 2/3 is 17 times 2, which is 34/3. And you can see that now we're getting sort of exhaustive of your ability to work with fractions. So now we're working with fractions, remembering those rules that we learned a long time ago. Don't rely on the calculator so much, but here we go. So I'm going to show you, if you didn't have a calculator, how you would do this, or the quickest way, in my mind. So 16/9 plus 34 times 3. 102/9 plus 18/9. And now it's just an addition game. Now it's just an addition game. 16 plus 18 is 34. 34 plus 102 is 136. And then we would look to reduce that. Oops, the camera's in the way here. We would look to reduce that if we could. And I believe they can be divided out by 3. Now, does anybody out here have a calculator here available? So if you do, divide 136 by 3. We know that 9 divided by 3 is 3. Or divide 136 by 9, although I don't think it's divisible. Is 136 divided by 3? Or we could also write as a mixed number. Okay? Okay. So that's one part of the lesson today. So let's get to the meat and potatoes. So the meat and potatoes comes with these two problems, and then we'll be done. You'll look here, in the second part is, how do we add and subtract polynomials? This is the easy part. So I'm going to show you, and there's no magical solution to this. It's just a matter of you recognizing that here's an x squared and here's an x squared. We are adding, and so we're going to be looking at 4 plus 2, and so that's 6x squared. Then we're going to be looking at x and the 3x, and that's 4x. And then we're going to be looking at the 7 and the 1, and believe it or not, that is your answer. That's your answer. So the first two examples, or three examples, dealt with plugging numbers in and evaluating. And then we jump to these problems where you're actually adding and subtracting polynomials. In other words, a collection of monomials or single terms. And there's going to be a key concept here. The concept is you're going to be adding or subtracting like terms. Like terms. Like terms. And so the last example I'm going to do is number 7. So you'll notice that number 7, we're subtracting. And so we want to be careful, and we want to be able to line up x cubed. 3 minus 1 is 2x cubed. Then we look for an x squared term. There it is. -1, positive 5. Negative minus, negative minus. So you have to be careful. -1 minus 5 turns into a negative 6x squared. There is no x term in the first expression, so we just rewrite it like that. And then finally, and if you're in class today, you can go back and watch this video. Finally, 8 minus 8 minus a minus. Minus a minus. What do we know about minus a minus? It turns into plus. So 8 minus a minus turns into plus, so you have plus 15. So your answer is 2x cubed minus 6x squared plus 4x plus 15. That seems like a little more complicated. And so I want to show you, you saw me do that problem one way. Now I want to show you a subtraction, the easiest way to do the problem. Raise your hand if you'd like to see an easier way to do that. Okay. And so the easy way is going to be dealing with a property that we learned called the distributive property. Raise your hand if you remember the distributive property. We just reviewed it earlier. So I'm going to take this out, and here's what I would do on this one. This is the easiest way. Is to first of all rewrite 3x cubed minus x squared. Rewrite the first one as is. Because we have subtraction right here, I'm going to multiply or distribute the negative into that expression. And so I rewrite minus x cubed minus 5x squared minus 4x plus 7. Now you can see this seems to clear that up a little bit with respect to how I approached it the first time. Because now, what's 3 minus 1? Well, 2x cubed. What is -1 plus a -5? -6x squared. -1x cubed has already been taken care of, so that's done. And sometimes it's helpful to cross these out. What's left is 8 and 7. You have a -4x, you have an 8 and a 7, and so that's why we get our final answer. And this is another way to look at adding polynomials. When you subtract, it might help to distribute the negative through first. Okay, we're going to conclude our video there today, and go back and rewind this, watch it again, rewind it, and review, pause, take notes, whatever you got to do. And then the rest of the problems are for your practice in class. All right, guys. I hope you have fun with these. This is exciting work, and I'll talk to you later. Okay, so we finished with the concept review. Keep in mind that a polynomial expression is either a numeric expression or a variable symbol. And in particular, monomial means one term. Polynomial means many. And I want you to underline in your notes, the degree of a monomial is the sum of the exponents of the variable symbols that appear, and the degree of a polynomial is the degree of the monomial term with the highest degree. So for instance, if I have x squared plus x, the degree would be 2. If I have x cubed plus x squared plus x, the degree would be 3. Okay? And so that will conclude and summarize our lesson for today.